All right, so today we're covering chapter 1, which is an introduction to networks. So the book kind of starts off kind of basic. It's not going to stay basic for very long, but we'll first talk about networking basics. Then we'll talk about different topologies that you may see. And then we'll also talk about how to select each topology, some of the criteria. We'll discuss some of that. And also segmentation of network. Not going to go too much into that, but that's kind of what we're covering today. Now, before I go too much, I would recommend that you take notes on whatever you don't know. Most of it should be found in the textbook, but if there is something you don't know, definitely great to take notes on it. Take notes however you like. If you want to use the computers, that's fine. If you want to use a personal computer, that's fine. If you want to use a tablet, cell phone, whatever, notebook, you have the option. So however you want to do it, perfectly fine with me. So we'll just kind of start off by talking about, in general, a network is just a connection of devices. So we can have just 2 devices, or we can have substantially more than 2. There's no real limit to how many we have, at least from the practical standpoint. Now, certain networks have a limitation. A lot of access points have a limitation somewhere between 100 to 255. Some can go up beyond that into the thousands, but for the most part, we're talking about a traditional network. We're not going to be limited to X amount of devices. And what the purpose of them is really to share resources between those devices. So we think about resources. Maybe there's files we want to share, maybe applications. Some cases we may share an internet connection. Maybe we want to share a printer. All those are going to be enabled by a network. So we see here, we have a little picture of a basic network. We have 2 host devices. Host is just a device that has an IP address on a network, and they have access to a printer. So really basic network there. So one specific type of network is a local area network. And as the name would imply, it is specific to one geographic location. So for example, let's say we had 2 buildings. Are they going to be a local area network? Yes or no? 2 separate buildings. They're not going to be a local area network. It's going to be specific to one building, maybe one department, maybe a home office, whatever we want to have. And the idea behind this is we have work groups that segment these devices. Now, don't worry too much about that for now, because when we get into talking about stuff like VLANs, that's where this really becomes a big thing. But for now, just understand that each of the devices on the work group are basically sharing the connection. They're all connected to the same switch, in other words. So it's a simplified way of thinking of it. And of course, we can connect different local area networks with a router. Without a router, we're unable to pass packets between the different networks. So talk about the different components a little bit. We have a workstation. So a workstation is typically going to be a desktop form factor, typically going to be a full-size tower, not a mini tower, not an ultra-small form factor, not a small form factor, a big full tower. And it's going to be built with server components. So it's going to have ECC memory. It's going to have server-grade processors. Typically, we'll have multiple physical processors, although it doesn't have to. The book says it has to. I'm going to disagree with the book a little bit there. There are certainly workstation devices that have a single processor. Don't believe me? Look up the T3500, for example. That's an example of a workstation that has a single processor. Still using server-grade components, but only has a single physical processor. Multiple cores, of course. Client is just going to be any device on the network. So cell phone, it's a client. Then, of course, we have server. A server is going to be something that isn't necessarily used for daily computing tasks, but instead does things like file sharing, printer sharing, all that sort of stuff. And then lastly, a host is just a device that has an IP address. Any questions so far? Well, as always, feel free to ask any questions that you like. So a wide area network is going to be a network that spans a geographic area. So unlike a local area network, we could have this be across multiple buildings if we wanted. And of course, we need a router for this. Why do we need a router? Well, if we have multiple local area networks, we can only connect them together via a router. Even a smart switch is unable to do that without the presence of a router. So the good thing about this is we can use public or private transport networks. So why is that a good thing? Well, first of all, let's talk about what a transport media is. So two major types. We have broadcast, which is going to be wireless signals, and we have cable media. Cable media, of course, is going to be a hardwired connection. Now, imagine we have two separate buildings. Let's say there's no way to run a cable in between them. Are we unable to have a network? No, because this right here, we can use a public media, so probably either going to be maybe some line from a service company, or it could be a microwave, something like that. So you use either broadcast media or cable media to connect the two together. We don't have to run a specific cable. Probably get better performance if we did, but we don't have to. So it's a very beneficial thing, and of course we would use different technologies to be able to do that. But the whole idea is that an internetwork is a connection of networks. Now, can anyone give me an example of an internetwork? Look at the word internetwork. The internet, that's exactly right. So as you can see here, we have different routers. They connect the different local area networks, forms a wide area network. So we have peer-to-peer versus client-server. So there's two different technologies we could use. So peer-to-peer, basically, there is no single sort of authoritative device. So when we talk about authoritative device, we're talking about a server. So the server here is going to store all the different user accounts. It's going to have all the different access controls applied to it. Probably going to be using something like Active Directory. Could be using LDAP, we don't know. But that's basically what we're doing there. And this uses hubs. Hubs, probably not going to see them very much in the real world. But, think about if we have peer-to-peer and there's no central authoritative device, how do we do things like file management? Is that going to be very cleanly done? In other words, maybe Mickey here has a file stored on his desktop. How do we back that up? Also, let's say Mickey here has local admin to this computer. How do we ensure that they're having reasonable security policies assigned to it? So the management is going to be very tricky in a peer-to-peer environment. However, in a client server, very simple. Use things like group policy to set policies for what a user can and cannot access. Very beneficial. Have access groups. So maybe someone in one department can access these files, and in a different department, they can't access those files, but they can access other files that are relevant to their jobs. It's all about having the least access role-based control. So role-based access control, that's what it is. So go over topologies a little bit. Topology is a fancy way of saying a map. So we're talking about this from the concept of a network. We're talking about a network map. So imagine we had, I took the expo marker. Here's one. So let's just imagine we have a basic topology in this room. Okay, so we have 30 different PCs. So I'm not going to draw 30, but I'll draw a few. So we have PC. Okay, just going to make a little box. PC, PC, PC. You get the point. So each of these are going to have a connection to some switch. Okay? So they're each going to have a connection to there. And that's a basic example of a topology. Simply a map. Any questions so far? And you can see there's lots of different topologies that we need to understand. So I'm just going to go through these kind of quickly. But the bus and the star. So the bus, there's a funny quote in the book. It's not an exact quote, I kind of paraphrase it a little bit. Resembles a bus that's been in a wreck. Now, why do we say that about a bus topology? First, let's talk about what a bus topology is. It's a case where you have a network and there's a single cable with a start and an end. And you basically splice off of that cable for each individual connection. So you can see here, the way I drew this was I have each of these having a separate connection. Now, that's going to be more in line with a star topology. So a star topology, each end device rather, has a direct connection to some switch or hub, but in most cases it's going to be a switch. So the difference between a hub and a switch basically is that a hub tends to send out every packet to every machine on it, and a switch is able to more intelligently send packets to the actual device using MAC addresses. So you're not really going to see a hub. It's really, it's just kind of legacy terminology. They do exist, but it's more of a thing in the 90s when it was a lot more costly to buy a switch. Now, I don't even know of anyone making hubs, so that's the difference there. Now, of course, that's not entirely, it's a simplification, but that's the gist of it. Does that make sense? Okay, so that's the main differences there. So basically, star is going to have a central connection point. It's going to be more fault tolerant, but is there still going to be a point of failure? So what's the point of failure with this? The hub or the switch, exactly. Because if that fails, none of the devices attached to it are going to be able to access the network. How can we avoid that? So there's a couple ways. One, well, they both involve some sort of a failover. So you'll see on the servers, a lot of times they have multiple NICs, network interface cards. And it's basically just a fancy way of saying a network port that allows you to have a MAC address tied to it. So the reason that exists is because it's going to have one connection to one switch and another connection to another switch, and maybe even a third or fourth connection for things like management. It's not going to be as practical for a desktop computer because let's say your desktop computer is not able to access the internet. Is that the end of the world? Is the entire college campus out of internet? No, just the devices attached to it. So that's what we're talking about. I think it's a lot more fault tolerant than a lot of other technologies, but that's what we're talking about there. Of course, there's also the point-to-point link where you would have the device, the central acting as a hub, and the device on the other end, which is going to extend the network a little bit. We're going to talk about that in a couple chapters, though, so don't worry about that for now. Okay, so next we have a ring and a mesh. So in a ring topology, as you can see here, there's basically going to be, each device is going to be connected to the next device. So, you can see there's going to be an input, and then there's going to be an output. And what's the problem with this? Well, yeah, so if any of these break, then they can't communicate with each other. That's one problem. What's another problem? It would definitely be slow because for every packet, it's going to be sent all the way around. And you can imagine, let's say we have a couple people streaming video, maybe some people downloading files, whatever. It's going to be very difficult to do that. What's another problem? So you have to have 2 network interface cards on each device. That's not cheap. It is cheap to run cable. So the book talks about the typical bus topology being less costly than a star topology. I disagree with that. Even if we were running in this room, just to splice 30 different connections, that's very costly. It's a lot cheaper to go out and buy a $100 switch now, isn't it? So I'm going to disagree with the book and say that sort of older ways, maybe it was less costly, but in modern day, almost always going to be more cost effective to go with the star topology. Mesh topology. So mesh topology is kind of interesting because each device on the network has a direct connection to every other device. What's one of the problems with this? So that gets really messy. You can imagine, are you going to be able to have a network interface card that can support 200-something wired connections if you had just a handful of devices? You're probably not. So the exact equation for this is going to be N, times N minus 1 divided by 2. So let's say we had 15 devices. So we take 15, multiply it by 14 divided by 2. Someone do that real fast. Tell me what it is. Do what? So you take 15 for the N, you multiply it by 15 minus 1, so that's going to be 14, and then you divide that by 2. 105, does that sound right? So it's going to be a large amount. Now, where this will be used, though, is for a lot of devices, particularly on the things like home automation, where you have Z-Wave or Zigbee. Those are going to be using a mesh. And the reason for that is because each device extends the range of the network. So you may have your hub that's going to provide connectivity, and then beyond that, each device can also extend the range a little bit. So it is used, but it's not going to be used in a wired setting. Does that make sense? Okay. So now we have point-to-point and point-to-multipoint. So these are going to be very common between buildings. Imagine you had two buildings and you had to connect them in some way. You could run a cable. That's certainly one option. But let's say they're 7 miles apart from each other. What are you going to do? So there's two options. One, virtual private network. Two, you could establish something like a microwave connection. Microwave, of course, is going to be using the broadcast media, and of course, a VPN is going to be using public cable media. So those are basically two options there. That's all we're really talking about. Point to multipoint is going to be highly related, and with it, basically, it's just going to be one device connecting to many devices. So it's really the only difference there. So you have one central corporate office, connecting all the branches. Any questions about these so far? All right. So now a hybrid, as the name would imply, it's going to be some combination of different technologies. So for example, let's say we are a campus. We have a place where the internet comes into the building, and we want to get that out to all the buildings. But within each building, we want a star topology. What topology is that going to be called? So any guesses on that? We're using multiple topologies. What is that called? Hybrid, exactly. So we're just combining two things. Really straightforward there. So you can see here, they're using star as well as bus technology. So certainly things you could do. Not sure why you would in that case, but you could. So when we think about which topology makes sense, what are we going to keep in mind? Well, there's a lot of different factors. So the most important one, I don't even know if this is in the book, but think about what the organization needs. What is their strategy? We're talking about this from a business perspective. What do they need to do? If they're a business that does not have any needs of technology and their strategy does not require it, do we need to have a network at all? Probably not. Let's say conversely, they're a company like Amazon that not only has a large consumer-facing front, but they also have Amazon Web Services and other things. What do we think we're going to need for the topology in that case? I think we're going to need to have a lot of redundancy, probably a high budget, just a lot of things like that to kind of keep in mind. Now, of course, the budget. So there's some amount of money that a firm can spend on whatever they're doing. And do we want to go above that? Why or why not? So let's back up a little bit. We're talking about an organization here. So organizations, especially publicly traded firms, you as a shareholder are going to expect that the key players, so the executives and people like that, maybe chair people in the company, board members, all that sort of thing, are going to have something called fiduciary duty. Who can tell me what fiduciary duty is? So fiduciary duty says that the executives and the chair and board people and anyone else with decision-making power, really, is expected to act in the best interest of the shareholders or the owners of the firm. And if we think about that, if we go above a budget, is that acting in the best interest of the firm? No, it's not. So we definitely want to consider the budget. If we don't, we could be violating fiduciary duty or fiduciary responsibility. Then we also want to consider redundancy. So redundancy is saying we have not only one way to do things, but multiple ways. So typically we'll see that in a typical rack, you have at least two of everything. So you have a router. Okay, let's say this is a router. You don't just stop at one router. You have a second router. And in addition, you often have multiple internet service providers entering these. Why would you have multiple ISPs? Well, let's say one goes down. Do you want to not be able to run credit card transactions if you're a retailer? You do not want to not be able to run credit card transactions. So we could use multiple wired ISPs. We could use a wired ISP and a broadcast ISP. A lot of these firms like Verizon, T-Mobile, they're offering 5G internet service now in select areas, of course. Not an advertisement for them by any stretch. But be a very cost-effective way to ensure that you have redundant ISPs. Also you want to do things like load balancing. Why do we want to load balance? What's the point of load balancing? Anyone know? So there's a couple of reasons we load balance. One of them is that with load balancing, we can ensure that we are not facing, or at least let me rephrase it, we can mitigate some potential attacks. So if we load balance, maybe half of someone's request gets sent to one router, half gets sent to the other. We'll talk about this more in later chapters. Don't worry about it too much for now. Just understand the basics of load balancing is that if it were all executed by one device, or one server, or one switch, whatever, could potentially be a cyber attack. Because it's split across them, it mitigates it. Doesn't eliminate it by any stretch, but makes it a lot more difficult. So anyway, we have multiple routers, redundant switches. That says switch. And then we have another switch. And a couple of reasons for that. First of all, does technology last forever? It does not. So because it doesn't last forever, we know that at some point these are going to go out. And when these go out, it'd be nice to have something we could easily swap over without having to wait for shipping. Just kind of an aside, does anyone in here get 2-day Amazon Prime? I don't get 2-day Amazon Prime. I pay for it, but I don't get it. It's more like a week for me. Kind of a bummer, but not the end of the world either. Now, with something like ordering a switch or router, as a business, you would probably spring for overnight, or maybe even same day in a lot of cases. But you don't necessarily have the ability. Why not just go ahead and purchase 2 switches that are redundant? There's really no reason not to. It is not that expensive, and it could save you a lot of money in the future. Now, that said, let's say you're a very small firm, say you're doing accounting work, and you're not running transactions on the day-to-day. Do you need to have redundancy? Say you're a small dental office. You don't have to reach the internet. Would you have to have redundancy? You would not. But let's say you're a large environment, maybe a corporate office, maybe a hospital, something like that, where you would need redundancy. So keep that in mind. Beyond that, it's very likely that, especially with servers, a lot of switches and a lot of routers as well, they use redundant power supplies. That means that if a power supply fails, the unit doesn't go down, simply switches over to the other power supply. And that can be done in real time. So you would literally experience 0 recognizable downtime with that. So speaking of downtime, that's another thing to keep in mind. Who could tell me what downtime is? Exactly. So we want to potentially minimize that, but we minimize that through things like redundancy. Having more equipment than is needed to perform the basic operations, such that if some of the equipment fails, we can easily fail over to the non-failed equipment. Another way we can minimize downtime, well, there's a lot, but of course, having multiple ISPs, all the redundancy stuff, but also having competent people. Imagine if we had people who are not competent. Or imagine we had an IT department that's overseas that only works from 8 to 5 in their own time zone. That's likely to lead to some downtime, wouldn't you say? So if downtime is something we want to minimize, then we definitely want to keep that in mind. Quick poll. Who thinks 99% is a good target for a corporate office for downtime? Okay. Who thinks 99.5% is a good target? 99.9% uptime. Okay. So a lot of times you think 99% uptime, that sounds pretty good on paper. But you think about it, there's 365 days in a year. Okay? So if we have 99 available percent, how many days is that going to leave us? It'll leave us 3.65 entire days where no one can access the services. And really it's 2.5 for leap year. So is that a lot of downtime? It's like 100 hours or so, give or take. 24 hours multiplied out, of course, that's going to give us a little under 100 hours of downtime for the whole year. That's a lot. Of course, we have 99.5. It's going to be substantially less than that. 99.9, it's only going to give us 0.365 days. So it's going to be a much better target, I think, for downtime. Now, the book says it's going to be very costly, and you can basically achieve it by having redundancy. It's basically all you have to keep in mind. Now, it's going to be redundant in everything, though. You will not want to have anything not be redundant. Does that make sense? So that if any one component fails, your network does not go down. Okay, let's talk about speed. Now, the book talks about speed, and I'm going to make fun of that in a little bit, but we'll get to that when we get to it. What sort of speed do you think we need for a corporate office? Well, we wouldn't want to have anything less than gigabit, but we'd probably want to have more than gigabit, especially for the equipment on the racks. So we'll talk about that in a little bit more. Security. Do we want to have an insecure network? Why do we not want to have an insecure network? What's the problem with it? Okay, that's one problem. So we have problems with losing that information. What happens if we lose customer information? Well, it could be a couple things. So we think back to the value of a firm. Okay, what is the value of a firm? Okay, assets equals liabilities plus stockholder equity. Okay, so imagine that investors place $1 million worth of value in the firm. Okay, we could have what's called intangible assets accounted for that. And with an intangible asset, could be something like goodwill. Could also be things like intellectual property, but we're just going to assume it's all goodwill. So if our firm has a data breach, is that going to increase or decrease the goodwill that the general sentiment is around the firm? It's going to decrease it. We want to avoid that. How can we avoid that? By having security. It's kind of a little bit of sort of circular logic there, but that's one way we could do it. Another problem with not having security. So we have that. What if we have downtime as a result of a cyber attack? That's also a bad thing, is it not? So it's another reason to keep security in mind. Now, with security, something like using switches instead of hubs, does that increase or decrease security? It increases it. Why does it increase it? Exactly. So we're only sending with a switch the information to the specific device. It's a very important distinction. Another thing with security. Let's say we have a wired network, or wireless network rather. Do we want to just leave it wide open? Can anyone access it? No security at all. No WPA Enterprise, no WPA2, not even web. Nothing at all. Is that a good idea? Why is that not a good idea? Exactly. Anyone could access it. That's going to be a big problem. So we definitely want to make sure we're using at least basic precautions there. Maintenance. Want to consider how easy a network is to maintain. So there's a lot of different considerations for it. Now, well, let's just back up a little bit. In the past, to manage a router, you had to basically go up to it physically. Now we can use things like SSH. We can use things like cloud management. It's a lot easier to manage. What's the benefit of having different sites be easier to manage? So I'll give you one benefit right now. Imagine we have a company, let's just say they're a physical retailer. Okay, let's use Walmart as an example here. How many stores does Walmart have? I don't know the number either. It's in the thousands probably. So do they have a network manager on each site? They do not. Why do they not? It'd be very costly. Let's face it, it could also be difficult to find a competent network manager in certain areas. So that's something to keep in mind as well. Some other reasons why they don't. Because they don't need it. That's the main reason. So imagine you have a network. You can manage it centrally. You can have all those operations done in one or two, maybe 3 or 4 spots, but not thousands of different locations. So keeping in mind where we can maintain it, keeping in mind how we can maintain it, how cost-effective it is, all those sorts of things. So any questions about these? So the book has some slightly different ones listed. Just make sure you understand what to consider. These are just some certain things you'd consider. So in most cases, or let's just say almost every case, what type of topology are we going to be using? Hybrid. Star is what we'll be using for most of the end devices, but in terms of actually looking and seeing for the whole network as a whole, thinking about the wide area network, it's almost always going to be a hybrid because we're going to be using at least multiple different types of network. Does that make sense? Okay. So let's talk about backbone and segments a little bit here. So really a central idea is we have the routers and the switches, and we have the different ISPs coming in. That's the backbone. So then from there, we send the signal off via the switches to different other switches. Those are going to be our segments. So the routers are going to be there to allow those different segments to communicate, and of course the switches are going to make that physical connection. So that's really all there is to say here. Now this is where the book talks about you want to make sure it's gigabit. Well, you want to make sure it's a lot faster than gigabit in 2021, let me tell you. I wouldn't go any less than 2.5 gigabits per second. Personally, you could go 10 gigabits per second, 25 gigabits per second, 40 gigabits per second, 100 gigabits per second. Probably not going to be dealing with 100 gigabits per second except at a very large corporation, but the technology exists. And of course, 20 years ago, gigabit was not very popular. So, it'll likely become more popular as time progresses. But, think about it. Even 10 years ago, most computers sold had a gigabit port on them. You can imagine servers definitely had at least a gigabit port 10 years ago. So I think that's pretty outdated in the book, something to make fun of, but not make fun of for too long. So talk about a campus area network and storage area network. So a campus area network and a wide area network are quite similar. The main difference is a wide area network can be on a larger geographic area, whereas a campus area network, we tend to think of it being constrained to a particular sort of contiguous piece of land. So what do we mean by that? So imagine we are a company and we have multiple sites that are not physically connected. Is that going to be a wide area network or a campus area network? So they're not physically connected. Wide area network. Let's say that we have one big plot of land like Fort Lewis College, and let's just assume there's only one campus, or there's only one piece of land that everything's on. What is that going to be? It's a trick question. It's going to be a campus area network and a wide area network. So personally, I don't make the distinction very often. You probably need to know it if you decide to take the network plus, but that is what the distinction is. This is going to be a WAN that is specific to a geographic area. Now think about this like you have a square. Is every square a rectangle? What's the definition of a rectangle? Something with 4 sides and 90-degree angles. But we're not assuming that each of the sides are equidistant. Now, if we're talking about this, it's going to be more specific, but it's still a rectangle. It is still a WAN. Does that make sense to everyone? Okay. Then, of course, you have storage area network. Now, basically, the whole idea of a storage area network is it's going to be a collection of drives, typically spanning multiple devices, that are on a separate VLAN, and they're going to allow you to do things like file storage. Network attached storage is a little bit different. It's going to be on the same network segment as the sort of main network. So that's the main distinction there. SANs are going to be a lot more popular in enterprise environments because they're easier to manage, whereas NASs are going to be a lot more popular in prosumer or maybe even some small offices, stuff like that. So that's the distinction there. But they're going to be pretty related otherwise. Just kind of wrap things up, cover the basics of networking today. We also talked about different topologies, when you would select each one, things like that. We talked about the backbone connection, where the service comes in and where it's distributed to the rest of the firm. And then we also talked about some basics of network segmentation. I should note that it does pick up and get a little bit more technical than this first class. This kind of lays the foundation, make sure everyone understands the basic terms we'll be talking about throughout the semester. Any questions? All right, that's it for today. I think next class we'll pick up talking about Chapter 2, I think. And I canceled class for Labor Day because who has class on Labor Day, am I right? So yeah, then Wednesday is Chapter 3. Have a good one, everyone.